This seems a little vague. So why don't we code it? Why don't we code our node? I will bring up a file. I'm going to leave it here. I'm going to make sure that it's narrow enough so that it can be on the screen, but we can leave our design there. And you'll start to see what I'm talking about. So we have our node on the screen. We have our node file, and we're going to define it as a class. Right? And the first question is, do we need this to inherit from anything? No, right? We don't need these, so we're just going to leave them out. And what's the first method we need to define when we define any class? Well, we need to establish the state that this thing is going to hold. So let's define our initializer. First parameter is always self. And then from here, what do we need to store? Well, we're going to need data, right? And I'm going to call it my element. And we're going to need a reference to our next node. So we'll call it next. Okay, now notice purple, right? Purple means that that word means something in code, right? It is reserved. It is not a keyword. It is not like def, right? I could not name my variable def. That would break. But I could name it something like next or print. The downside with this is if I needed to, if I named my variable print, for instance, and then I came down here and said print, it wouldn't know what to do. I've redefined what print is. Similarly, if I do this, I'll redefine what next means. Now, I may not be planning on using next. In fact, I'm not planning on using next. But I will tell you, it is generally good practice to leave words that already have meaning in your language alone and just come up with a different variable name. So we'll call it next node. Okay. So the issue now we have to ask ourselves is this good enough? Well, from a data standpoint, yeah, but what about from a usability standpoint? Are we ever going to have a situation where our next node is going to be, I don't know, undefined? We don't want to define it when we start. Well, yeah, the last node in any linked list is always going to have an undefined next node. Okay. Well, we can kill two birds with one stone then, right? We can just set it to none, which means it's undefined, but is also what the last node in a linked list points to. That's great. What about element? Are we ever going to have a definition where element should be a default or nothing at all? Well, yeah. I could think of one real easy. I define my node at the beginning, and then I do some processing, and then I decide what goes into it. So why don't we do this? Why don't we make it none, none, and we're good to go. And now all we have to do is save them into some instance variables, and it helps if I put the dot in there. Okay. And I'll put element in, and then I'll do the same thing with next node. And I won't call that next node. I don't need to. I'll just call it next. That's okay. It's an internal name, and it's not purple. So we're good. Okay. Well, to model the good behaviors that I tell you, let's test it. Let's test it right now. Okay. Let's come over here. Well, too big. Let's come over here and let's test this. And let's go n equals node, and we'll give it 1, 2. N dot underscore element, N dot underscore next. Beautiful. We gave element the value of 1. We got 1 in there. We gave next the value of 2. We got 2 in there. But should we have 2 in there? Well, yeah, obviously we should. I gave it 2. But is it supposed to take an integer? Well, no, it's supposed to take a node. Now, remember, I've told you that you do not need to check inputs unless you want to, right? We could absolutely, do something like assert next node is none, or type next node equals node. We could do something like that. You don't have to. That is not something that you need to do. But it is also something that we shouldn't do over here. So what if I wanted a second node, but I wanted 2 inside of that node, right? I want 2 as my second element. Well, how do we create a node? We'll just call the constructor. Hey, now look. Now I have a node that has an element with 1 in. Then I have a next node after it. And, well, how do we get that element? Well, n.next is a node, right? It's the node we're looking for. So I can just call dot element, right? I can chain the calls together and get dot element. And then nothing, right? If I print that, and I put the parentheses there, so it's a well-formed statement, none. So I use the one default constructor, the one default parameter, right? I say, hey, my next one's none. I want a node with 2 in it, and then I want a node with 1 that points to a node with 2 in it. Hey, look, I made a linked list. That's it. That's what a linked list is. But what about this, right? I spent a lot of module 2 saying, don't directly access the hidden variables. Is what I'm doing here illegal? And the answer is sort of. It's okay now because I'm testing, right? And you should test early. And the nice thing is, as simple as this is, now when I do some later code, I can assume that my constructor works. So it's absolutely okay when you are testing to access the hidden aspects in order to make sure that your objects are being created properly. But we do need to provide an interface for people so that they can get to this stuff without needing to know what's going on behind the scenes. So let's do that. Let's start creating some other variables. We'll call the first one, we'll create getters, right? We need to create getters. And we'll do our 2 accessor methods for our 2 data points. So get underscore element. And do we need anything other than self? Well, all we're doing is getting the element. The object has that information already. So I can go, cool, return self dot underscore element. And then we'll do that again. And we'll do that for get next. And we'll just return self dot underscore next. Okay. Now, I can run this. Right? Save, run, it'll pop up. And then I can do what I did before, right? And I can do things, and I can just tweak. Or we could come back over here and we could write a test bed. So that's what we're going to do. And we're going to do it in a way so that if we run this code directly, notice what we have here, main.node, right? When we run this file here, anything that's running in this file will be in main. If this file is called from somewhere else, like if this gets imported somewhere, the namespace, it's not technically a namespace, but we're going to roll with that. The namespace will be node. Node will be the primary thing. So we can just say, hey, if name equals main. And we'll just run it and we'll say print, I'm here. And if you'd like evidence that this works as I'm saying, I'll bring over this file, double node, which we'll work on later, and I'll import from node, import node. I'll save that. I'll bring up the Python shell. I'll run that here. Nothing, but I can still say n equals node. So you can see that my code ran, but I'm not in here. So we'll kill the shell. We'll nuke this from orbit. We'll come back to this later. But what I can do then is I can grab my test bed here, right? And I can just throw it in. And I can say, cool, print. And let's test some things. Print n.get element, right? And I can print n.get next. And I can confirm that I have a node there, right? And I can just recreate what I did over here, but now using our methods. We'll space them out. Technically, well-formed Python, there's supposed to be 2 spaces between method calls, so we'll do it right. And we'll go n.get next, .get element, and we'll go print n.get next, .get next, okay? So we'll run. And look, our first node has an element of 1, then we expect a node, and we got one. And then our second node has an element of 2, and then we expect no node, and we have none. So the system works, great. So we can delete this stuff, right? Don't do that. Leave it. Here's why, right? We ran these to confirm that these work. God forbid you make a change in the future and something stops working, right? If we create a new method and it tweaks things, we might find out, hey, we've accidentally altered our state variable or somehow altered something that affects one of these methods, and the methods don't work anymore. So every time we run, we're just going to add to our test bed. We're only going to remove test cases that are no longer relevant, as in they've been deprecated, right? The functionality's been removed, or that have changed functionality. And then you're not even really removing the test cases. You're altering them to meet the new features of your object. So great. So now we've established, as far as we can tell, these work. So let's keep going. What else do we need? Well, what if element or next node come in as none? Or what if we want to change what our node's pointing to? Okay. So let's do that. Let's create some setters. So we're going to create set element, and we'll need self. Is this going to need more parameters? Well, yeah, we're going to need our new element. So let's just call it that. Hey, this is our new element. And it would absolutely be acceptable if you had just said this, not return. If you just said, hey, self dot underscore element equals new element. That is sufficient. If you wanted to return the old element, which sometimes you might want to do, you could just create a variable called old element and say equals self dot element, right? Hey, we'll store what was in element, and then we'll return it when we're done, right? So, hey, grab what was in element, put it into a variable, overwrite the element with our new element, and then return our old element. And that would work. Right? We can just go, cool. Let's create a third variable. Let's create a third node. We'll call it N3, and we'll create it with a default, right? We'll test the default constructor. And then we can go and confirm that N3 has no element or no next, right? And then we can set our element, right? We could go n3 dot set element, and we'll set it to 3. And then we can print this again. And we can just test it real quick. Beautiful, right? Maybe we'll throw a line here so we can at least keep things sane. Understand where our breaks are. Beautiful. By the way, are you seeing now why the tester code has so much scaffolded information in there? Why I put formatting in there so we don't lose our way? Because this is a nothing object, and my test code is longer than my actual code right now. Okay, let's go a step further. What if we wanted our set element to be immutable? What if, instead of being able to change our element anytime we wanted to, what if we only wanted to be able to set it one time, whenever our element is none? Right? So if we create an empty node, like we have now with N3, we should be able to set it. But then what if we said, hey, let's come down here, let's set it again. Let's set it to something that will be obvious. And we'll set it to tacos, because tacos rule. And then we can print it, and we can see. Right now, we're going to allow that. So we can see here our test case, it failed. We got to fix something. Well, how would we do that? Well, we can just say if our self dot underscore element is none. Or if you want to be even more software engineering-y, this is totally acceptable, by the way. This is an absolutely fine statement. What's the thing that's responsible for getting the element? Get element. So if we get our element ends none, we should say, hey, you can update. Otherwise, we shouldn't update. Hey, now our code works. Huh. This returns none. Well, yeah, any code that doesn't hit a return statement, and if we're set, right, this is our element's not none at this point. Any code that doesn't have a return statement like this returns none by default. So what we did here with our old element and our return old element, sort of redundant, but we'll leave it there. It's fine, right? It's not broken, so we'll leave it alone. Cool. Last thing we need to do the same thing with our set next. So we'll do set next. And we'll change our next. And then, do we want this? Well, if we do that, and we might, who knows, right? But we're not going to. If we do this, then we're never going to be able to change the ordering of nodes. Once a node is established as being behind a secondary node, right? It's pointing to that next node. Once that next is established, if we leave this as, self.getNext is none, then we're never going to be able to change what our nodes point to. We don't want that. Maybe you do in some code. That's fine. Okay. Remember, design decisions. There's nothing wrong with that if that's what you want. In this case, it's not what we want. Now, you can leave these variable names. You have to change self.element to self.next. Right? You can technically leave old element as old element, but I'm going to tell you not to do that because it's going to confuse you. It would confuse me. So make sure that your names are your variables are well named. Okay. So now let's go through and let's test how if this works, how this works. Well, what could we test on? Huh. Well, what if we made a linked list of 3 nodes now? Right? So we can print, let's see. We'll print N3. Well, we don't have to print .get next because we did up here. Right? So why don't we just move it down here? So now it'll print none. Yeah, we'll leave it down there. That's fine. It'll print none, and then it'll print 3, and then it'll print none, and then it'll print 3, and then it'll print none. That's what we have right now. Okay, cool. And now let's test. Let's test our set next. Well, we'll set the next to this one. Oh, dear. How do we get there? Well, it's the next of this one, which is n. So we can go n.get next, and that will get us the node with 2 in it. And then we can call set next. And what do we want to set it to? Well, we'll set it to n3. And then we can go, cool, well, let's test our chain. Let's grab this again, right? This is our code. So we've got 1, a node, 2, a node. And then we should get, right? We're going to get next from n, that'll be 2. We're going to get next from 2, that'll be 3. So we should get, let's fix that. One node, 2 node, 3 none. Yeah. So this is it, right? This is the code. Let's see. Yep. This is how a node works. This is it. Okay. Notice the amount of testing we did, though. This is 54 lines of code, and I'm at 26 here. So literally half of the code is test code. Okay. So be sure that you do this, right? It is incumbent on you, even if being provided with the tester. It's incumbent on you to run some test cases as you develop to make sure things are going right. Because by the time you get to any sort of test code that's been provided, you're going to be knee deep in your development. And finding out what's wrong if you don't test everything as you're going forward, finding out what's wrong is going to be tricky because you're not going to know where the error is.